Now we get to talk about a new function, and these are some really cool functions. These are logarithmic functions. Sometimes they get a bad rap because they're a little different, so people tend to think they're hard, but we're going to go through what they mean, and you'll become an expert in logarithmic functions. So, the whole reason we need to learn about logarithmic functions is that they're actually the inverse of our exponential functions. So remember, our exponential functions were these functions a to the x. And remember, an inverse is something that undoes it. Well, our logarithmic functions, we'll call this log base a of x. So we had a base for our exponential functions, and that will be the same base on its inverse. Okay, so let's talk about what it means with a concrete example. So this says find the inverse of 2 to the x. Well, before we even do that, let's just look at what 2 to the x does. So if we write it as tables, 0, 2 to the 0 is 1. 1 would be 2 to the first power, which would be 2. Plugging in 2, we'd have 2 squared, which would be 4. And 3 would be 2 cubed, which would be 8. Well, now we need a new function, our inverse function. And let's just say x, and then we'll say inverse of 2 to the x. Well, now remember, we're going to plug in what we got out over here. So 1, 2, 4, and 8. And what we're going to get out is what we plugged in. So 0, 1, 2, and 3. Okay, so what does this mean? Well, remember our process for finding inverse? So if we want to find the inverse of f of x equals 2 to the x, we'd say y equals 2 to the x, and then we would switch the x and the y. So that would give us x equals 2 to the y. And here's where we run into a little problem, because remember our next step was to solve for y. And right now, we don't know a way to solve for y. We can't, it's an exponent, so we can't just divide. It'd be something like, well, we really have nothing like it. So let's write out what y means. Remember when we first talked about functions, when we said, well, sometimes you can write them kind of as an expression. So here, y is equal to the exponent you put on 2 to get x. We're saying what exponent do you put on this 2 on this base, and you get out x. That's what our y is. So from our example here, we're saying if we had 8, we plugged in 8 for x, we would want 2 to the y. Well, what would y have to be? Y would have to be 3, the exponent you put on there. That's what we just answered there. And now, this long phrase, we wouldn't want to have to write that out every time we want to talk about the inverse of 2 to the x. So that's where this word log comes in, okay? That's how a log was invented, or what it means. We're going to call this log base 2 of x. So what y is equal to is the exponent that you put on 2 to get x. So here, if we want log base 2 of 16, we're saying, what exponent do you put on 2 to get 16? Okay, and if you need to play around a little bit on your calculator, you could. Right, we already know that 2 cubed is 8. If we multiply that by another power of 2, so that'd be 2 to the 4th, we get 16. So this answer would be 4. Okay, well, what if we want to find out what log base 2 of 128 is? And we'll have ways to do this in a little bit, but right now we're just kind of exploring with our calculator. Well, one thing we could do is in our y equals, put in 2 to the x, and then look at our table and say, okay, where do we get out? I'm obviously way too big. Where do we get out 128? And we see that happens when our exponent, our x, is 7. So log base 2 of 128 would be 7. Okay, so kind of the key piece about logarithms is the answer that you get out is really an exponent. It's the exponent that you put on the base to get that number there.